All right, well, the first thing we ought to do is just do some introductions. Let me just say I don't have much in the way of lecture. I've only got a couple lectures in this course that is mostly going to be hands-on projects. You should all attain this certification. It's not that hard to do. You can certainly do it in 2 days here, I would think. And I'll be around to help people. But you should at least get that, and then you can go on and do things beyond that, including setting up IPv6 on these routers over here. All right, well, I got a bit of an introduction here. Although it sounds like you people may not need a whole lot of motivation to care about IPv6. But let me just start out with the usual stuff, because you may need, some of it may be new to you. I know quite a bit of it's new to me, because I didn't care about IPv6 until about a year ago. I mean, I tried it 3 years ago. I tried to get everything up to IPv6. It all came out in the 90s. As you know, it's been around forever. Around 2007, I got excited and I tried to get it to work, and I tried to get home routers and replace the operating system with Linux and get them up to IPv6, and it didn't work. I spent weeks with my best students working on that. I just got frustrated, and I said, you know, you can't get IPv6 service at your house. You can't buy anything that'll route it in if you get it in your house, and this is just for the birds. If I was to teach anybody anything now, it wouldn't be any good anyway. I got to wait until it gets ready for prime time, where I can teach something that you can use. And now that has happened. But the thing that made me give up completely is I said, well, there's class D and E just sitting there. 32 perfectly good, 16 million size blocks. They'll just repurpose them and use them for general purpose, and we won't even have to worry about this for another 5 or 10 years. But I went to a conference about IPv6, and the Aaron was there, our regional internet agency that hands out the numbers, and they said they're absolutely not going to hand out class D and E. They've changed IP version 4 3 times already. They are not going to change IP version 4 again. Forget it. Bite the bullet and go to IP version 6. And that means they're really going to run out of numbers, and that's the end of the game. And that is really happening right about now. So that convinced me to take another look at IP version 6, and in my absence, things had progressed to where it's actually practically reasonable to do hands-on projects with IP version 6 now, which it didn't used to be. So that's why I decided to get into it, and it worked out very well. Now, I'm supposed to have an audience response system, actually. We'll just skip this until later, because I haven't got it yet. We got to track down Ann. We'll just skip those for the moment and carry on here, because I can get you started on the hands-on projects, and after that, then we'll carry on with that stuff. So this is the end of the world. The internet will be over. At least as far as the IP version 4 internet, you can't add any new devices to it without network address translation pretty soon. Now, as you know, if you have an IP version 4 address, that's 32 bits, and there's only 2 to the 32 of those, and that's not enough. That's only 4 billion total addresses. They have been in units of 16 million blocks. They've been going down since the 90s, and the projection was that they'd run out right about now, and that is really happening. Now here's the entire IP version 4 address space. This is the first octet, so class A, B, and C, and here's that good old D and E that are just going to go to waste. Maybe 10 addresses in class D are actually used for multicast for routers, and all the rest of these are just going to go to waste. I couldn't believe it. This whole line, 16 class A's for E, experimental future use. Well, it's the future. Why aren't we using them? But no, they're just going to wither on the vine and never be used. Anyway, that's the way it goes. So here's A, B, and C, and here's how bad the situation is. This is why it's ridiculous it's not already in our textbooks and certifications. Here's what happened in January 21 of 2010. There were 24 blocks available. And then you go to April and May and November. So that's where we are now, and this is even worse than it looks, although it ought to look pretty bad. They handed out 4 of these 2 weeks ago, and the way it works is there are 5 regional internet registries in the world, and in order to avoid any argument about favoritism or anything, when the 2 more of these are assigned, the last 5 get assigned instantly, 1 to each registry. That's been the deal. And that's the end of the game. And that is expected to happen by March. So we have now 2.5 months before the end of IANA's pool of IP version 4 addresses. Now, that will not be the end of anyone being able to get IP addresses. It will mean there will be no more in the master reservoir. The 5 regional internet registries will still have some, and they won't start running out until the end of next year. But then somebody is going to go and ask for IP addresses and get told no. And so here's the 5 internet registry regions. LACNIC, ARIN's the one that covers our part of the world, APNIC and RIKE. APNIC is the main consumer because they're having a big boom in technology over there. Asia Pacific, they're sucking up the addresses like crazy. We got a lot of ours long ago. But anyway, so for the rest of next year, these will continue to hand out addresses, but it's just like so many global crises, like fresh water and everything else. There's a reservoir that's running dry, and people don't notice because when they turn on the tap, it still works. But the people that are thinking about it at the higher levels know that a disaster is coming. So people that build IPv4 only devices are living in a dreamland. There's no way they're going to be able to connect those devices much longer to the internet. So what's going to happen is somebody is going to get hurt, because almost nobody is getting ready for this transition. We were supposed to have 10 years to get ready, but everybody ignored it until the crisis. It's already happened that ARIN inspects your requests for IP addresses. Internet service providers have to submit a proposal, and they have to say, first they have to demonstrate that they've used 80% of the block they had before, and then they have to explain why they want more, and have like a proposal and convince them that they seriously are serving customers of some kind and they're actually going to use them, or you can't get them because they're watching to see if someone's going to hoard them and scalp them. Because and they decided that there are only 2 possible futures. One where you have a black market in used IPv4 addresses, and one where you have a white market in used IPv4 addresses, and they opted for the second one about 3 months ago. ARIN changed their policy and said it is now acceptable to sell your IPv4 addresses. And that's what I want to do. Our college has a Class B. We have 65,000 IPv4 addresses. We're only using 30 on public-facing web servers. So I said, we need money. We're broke. We're canceling classes. We should sell our IP addresses to raise money. Now, right now, you can get them a lot cheaper from ARIN, but that will end next year. And so I predict in about 2 or 3 years, we probably can get $1 million for our Class B. And we need $1 million, a whole lot more than we need to Class B, because I'm planning to convert our college to IPv6 next semester. I'm teaching the IPv6 class there. We're going to practice on our routers, make a model, and then start moving on. And so the companies that refuse to upgrade to the new system will have to scramble for the depleted supply of IPv4 addresses and buy used addresses from people that are smarter than them, that have already converted. And that will be the future. Of course, IPv4 won't end for a long time. All the legacy devices, all the legacy web servers and everything will continue to run for another 10 or 15 years. We're going to need both systems together for the next decade or more. But in the long run, IPv6 will replace IPv4. And here's a counter. A couple days ago when I made this slide, it was 81 days remaining of IPv4 estimated before the main reservoir runs out. Some people say this is deceptive because the regional internet registries haven't run out yet, but they will within a few months after that. So IPv6, there's an IPv6 address, long and horrible, which is the whole point. There are enough of these, 128 bits instead of 32. You write it in hexadecimal, which is really nice because students don't have to convert decimal to binary anymore, which seems ridiculous. Why do you take a binary number and write it in base 10? Just to give yourself an endless line of headaches. Anyway, so just forget it. That's why, in fact, when I'm teaching Cisco, I teach my students hexadecimal anyway. I say hexadecimal is the way to get from binary to decimal efficiently, so let's not bother with decimal at all. This is just hex. You can skip unnecessary zeros, and once in the address you can put in a colon to mean a whole range of zeros. Enough zeros to fill it up to the right total, but you can't have 2 of those. And that's the game. This is, of course, enough addresses forever. 2 to the 128 is an absurdly large number. 340 billion, billion. We're not going to run out of them anytime soon. So it's been pushed by the government, not by legislation, but by purchasing power. The Department of Defense ruled that they would have to have their devices all IP version capable by 2008, and they made that deadline. So for years before that, you couldn't sell anything to the military that wasn't IPv6 capable, so everybody had to put it in everything they wanted to sell. Microsoft put it in Windows 2000 and in Windows XP, kind of imperfectly, and in Vista and Windows 7 very well, very capable. In fact, probably too capable. And I know it's certainly true at my college when I tested it, and probably true everywhere else. If you have Windows 7 in your desktop, you have people that are connecting to the internet through IP version 6 and you don't even know it's happening because automatic tunneling occurs. If you put a public address on an endpoint, it automatically connects us to a 6-to-4 relay, which are open relays out there, on the Anycast IP version 4 address space, 192.88.99. I didn't even know any of this existed until a few weeks ago. I went to a machine to do these projects in the lab, started doing them, connected to the internet over IP version 6, and I said, wait a minute, I didn't install the tunnel client on here. How is this even getting out? Because we have only IP version 4 infrastructure, but you don't need to install the tunnel client. It automatically tunnels if you put a public IP address on the endpoints, which is a weird thing to do. And we do it at our college because we have these 65,000 addresses and we don't need them, so they stick them right on the endpoints in some of the labs. So I was actually using a public address, which is an unusual thing to do. Anyway, so the endpoints are all IPv6 capable to some extent. So they can sell to the military, and the feds are all switching over too. The non-military part of the US government will switch in 2012 to IP version 6. So again, for years you couldn't sell anything to a non-military government contractor without it being IP version 6 ready. So that has created pressure to cause a lot of devices to be upgraded to IP version 6. So the end devices are there. OS X supports IP version 6, Linux does, Windows does, and the problem is the stuff internet service providers need is not there. The routers work. Cisco had it in routers for a long time, but a lot of other essential things you might want, like load balancers, do not exist for IP version 6. And NetFlow does not exist for IP version 6. You can't monitor your traffic. And I went to the IPv6 Implementers Conference at Google, and Juniper and Cisco representatives were there, and I thought they were going to get lynched by this 300 people running ISPs saying, my customers need IP version 6 now. What's going on? And Cisco doesn't even have an IPv6 website. They had one, and they had tied it to only receive requests, only accept requests from one MAC address. So only the one laptop the guy brought could see it. And yet the guy said, all right, you guys, what are you using as a load balancer in front of that website? And he said, we have a Linux box. Because they don't manage it. And they said it'll be 18 months before they have NetFlow and load balancers that work on IP version 6, and they were not happy. So the enterprise level equipment you need does not all exist. You have to work around it, but you can certainly get started now right away. So anyway, there's the summary. This is IP version 4, and IP version 6 is inevitable. You cannot stop it, so you better accept it soon. That's the plan. So to migrate, the most popular plan by far is number 1. Just ignore it and pretend nothing is happening. This is, as far as I can tell, what 95% of everybody is doing. Every conference I go to, I give talks on IP version 6, and I ask people, and they say they don't care, they have no interest. They just thought they'd hear my story because they thought maybe I was crazy, but they really don't think, they think it'll be years and years before they have to do anything. And Aaron has reverse conferences where they go to conferences like the Consumer Electronics Show, and they go to the vendors area and they interview the vendors one by one. They call it a reverse conference, where instead of having a booth, they go to the booths and they harass them. When are you going to make IP version 6 ready stuff? And they went to the major manufacturers of home routers, and they told them, we have no interest. We don't even care. Until the consumers demand it, we're not going to do anything. And he said, the consumers have no clue. They don't know they need it. They don't know they're on IP version 4. They don't, that's not usually something they care about. But they said, when the consumers demand it, we'll just put 100 engineers on it, rush something together, put something together in a week, and that's what we'll have. So this is what we can look forward to, getting equipment made that way to network. And realistically, there are going to be 6-to-4 gateways. There are 4 different incompatible systems of connecting 6-to-4 together. So it's going to be real fun in a few years, making somebody's local network connect to somebody else's local network through some half-broken gateway, through another incompatible half-broken gateway, making the ports match and stuff. That's what they're going to need a lot of highly trained network technicians, which is why I was motivated to get my students ready. Because people are going to, in about a year or two, some company is going to make 30 million gadgets, like the new iPad or something. They're going to manufacture them, and then they're going to say, okay, connect them to the internet, and they're going to go to their internet service provider and say, I'm sorry, we cannot connect them to the internet. All we can do is give you RFC 1918 private address space, which will not give you the performance you need. And they ran out of that. You know, Sprint, I think it's either Sprint, I went to a conference, I'm pretty sure it was Sprint, might have been another provider. They said they ran out of RFC 1918 private address space so much that they've overlaid it 40 times on their network for cell phones already. There are 40 cell phones with the same 10-dot address, resolved through 2 layers of NAT already. So anyway, somebody is going to manufacture something and get hurt for lack of IP version 4, because they make something that only speaks IP version 4, they're not going to be able to get the addresses they need. And that's going to send shockwaves through the industry, and then every executive is going to call their networking department and say, please turn on the IP version 6 by Monday. And they're going to find out that it's not that simple at all. Anyway, so the gateways are what we're really going to end up with at a lot of homes. Homes are going to have gateways, and ISPs are going to have gateways, which they already do. Sprint already has one. Sprint deployed IP version 6 phones. They have 6 and 4 addresses, dual stack on each phone, and they have gateways to convert them. Anyway, there will be gateways that convert them. There will be tunnels, which is what we're going to use here, where you can take an existing IP version 4 infrastructure and tunnel IP version 6 traffic through it. This is the fast way to get IP version 6 going now without having to upgrade all your equipment. Of course, it doesn't really solve the problem because you still need IP version 4 addresses, but it'll get you started. Dual stack is the recommended procedure for the transition period, which will last for the next 10 to 15 years. Everybody's going to have to support IP version 4 and IP version 6 on your network, on your web servers, on your email servers, on your routers, everywhere, because you're going to have people out there that have IP version 6 only devices trying to get to you, and you're going to have people out there with IP version 4 only devices trying to get to you. So you're going to have to support them both if you want to serve all the customers. And of course, eventually, IP version 4 will be deprecated enough that it will not be significant, and you'll actually be able to have IP version 6 only devices, and you can ignore those small number of IP version 4 people that try to contact you. This may happen eventually, but that's a long way off. Anyway, so tunnels are the easiest way to go. There are free tunnel brokers out there. GoGo6, 6SS, and Tunnel Broker, which is Hurricane Electric, all give you free tunnel brokers. GoGo6 is by far the easiest because it runs on Windows. It penetrates network address translation. You can have a private IP version 4 address behind as many layers of NAT as you like, and it will find its way to the server and tunnel out, which is awesome. These others don't have that property. Tunnel Broker does what it's supposed to do. It puts 6 in 4 as protocol 41, which is a layer 4 protocol. It's not TCP and it's not UDP. It's another protocol. And the problem is home routers do not know what that is and they don't let it through. I don't know any home router that lets it through. The only way I've been able to succeed in doing it myself, or any of my students have succeeded, is by moving your one computer into the DMZ, so it's completely on the other side of the router's firewall, which is a poor security practice. This is why one thing I've heard some people stand up and say at conferences is, IP version 6 has no security implications, it's just the same as IP version 4, which is, you know, I feel like throwing things at them. Yes, in theory, you could have the same security appliances for IP version 6 as you do for IP version 4. In theory, there are never security problems. Security problems are always because of what you really have to do to make things work. And what you really have to do to make IP version 6 work is to trash your security completely. In most cases, you have to bypass the firewall, you have to bypass the VPN, you have to, and there's, anyway. Eventually, there could be comparable security in IP version 6, but most implementations in the short run trash security to get going. So the GoGo6 client, you just install this Windows thing, and it connects automatically to their free servers, which, by the way, are pretty overloaded and flaky, and will go up and down on you and frustrate my students. But they're better than nothing. So the GoGo6 client should be running on this thing. Let me just run it right now. And this will be your first, GoGo client. There, GoGo client utility is just a free download. You run this thing, and I'll show you how to do it in a minute, and you can all get started. I know at least one of you was telling me at breakfast he's already got this far. This gets you through an IP version 4 infrastructure and connects you over IP version 6. So it should come up here in the fullness of time. Well, that's coming up. I'm going to get my command prompt up. Okay, so if I do, there it comes. All right, so there are different kinds of tunneling mode, but I put it on the default, which will just try them all until one gets through. The one that usually gets through is IPv6 in UDP. You do have to have the UDP port open. I think it's 5461. It's in the project, 35. I forget the number. If your network blocks that UDP port, that blocks this. That's the one irritating thing. You can't have everything. which in fact this college might. Let's find out. If I ping 8888, that's one of Google's servers, and that's there. If I ping google.com, good. See, google.com responds with IP version 6 and IP version 4, and it prefers IP version 6, so I am an IP version 6 machine. I just connected to it over IP version 6. You can tell that horrible, that's not an IP version 4 address. That's an IP version 6 address, and this colon means 4 fields of zeros are there. By the way, there was a chance you could participate in the development of IP version 6. There was an RFC that came out a month ago to try to name these things. Now that is an octet. This has 16 bits and no one knows what to call it. And there were about 22 options and you could vote. I voted for Word because I was thinking of like C and C++. But somebody else had some other, like a sextuple or something. There's a whole bunch of, and there are a bunch of really weird things like squibble or something. Anyway, I forget what's winning. But actually, there is no correct term right now for that thing. So I'm calling it a field, if I can remember. But you could participate. I think the voting is still going on to determine what word will become the correct term for this, which is something you think someone might have resolved in the last 15 years, but no. So anyway, that 16-bit object, there are 4 of them you can see and 4 hidden ones there. Now, what's that?
I like hextet.
Hextet. I think hextet was one of the choices. Yeah. Yeah. And I think, anyway, so that's the...
But if you say it badly, you shift it to an S in the front.
Yeah. Yeah. Well, I think anyway you cut it, there's going to be some undignified things here. Anyway, here's some companies that are already on IP version 6. Google's on. They have their IP version 6 only server. If you want to test your machine, you go to ipv6.google.com. You can ping it and you can open it there. This is IPv6 only. Then you got Facebook, which has a weird one. They've made it redundant. www.v6. That's the, I can never get it right. www.v6.facebook.com. Now, the original plan was everybody will make both quad A and A records in their DNS. Now, let me just show you how this works. If you do NSLookup of google.com, by default, the NSLookup will now do a version 4 and a version 6 lookup. The version 6 is here. Here are the many version 4 addresses. You can see that the version 6 presence of Google is not yet multi-homed for load balancing because they're not getting much traffic. They're getting quite a bit of traffic on YouTube from France. That's the main consumer of IP version 6 traffic at Google. But if I do NSLookup in interactive mode, I can get the whole story here. Set Q equals any or all. I forgot. I think it's all. We'll try that. Yep, that's the whole story. Okay. So let me just maximize this. All right. So here's the MX records for Google. Here's the quad A record for Google, because the A record is the address record that points to an IP version 4 address. So they named the IP version 6 one AAAA because it's 4 times longer. There's the quad A record, and down here are the A records. So probably as far as I want to go there, I'm thinking it might be time to just get you folks started on the search before we even go any further here. Then I can move on to the iClickers. So what we're going to do here is go through this certification process. Everybody should finish and achieve this certification during this class. It's not unreasonable to achieve this in 2 days of classwork. You may, in fact, you people are so advanced, you might finish it the first day and we'll just go on with the Cisco stuff. But you first connect as a client, then you have to set up a web server, then you set up an email server, then you have to spend all the rest of the time fixing your DNS. DNS is actually pretty much of a mess, and there are many, many corrections you have to make to your DNS presence to get it working. The first thing is you have to get forward DNS and reverse DNS, because reverse DNS is commonly used to screen spam email. So you don't really have an email server that's worth anything until it can have reverse DNS work. And that turns out to be kind of a challenge. The hardest part, which got a lot of trouble at Hurricane Electric over this, is to become the highest level, a sage, you have to get your domain resolved with a glue record at the root of the domain name system. And I'll talk more about that later, but that is beyond your control. You can't do that. Your domain name registrar has to do that. And you have to choose domain name registrars that offer that service, and they are not thick on the ground. So that is why in order to achieve this certification, the way I'm doing in this class, you must spend money. You must spend $2.17 to get a real domain name at GoDaddy. As far as I can tell, there is nowhere else you can get a domain name that will actually work. Because GoDaddy is technically excellent. I have problems with their politics, but their technical excellence is fantastic. They really support IPv6 all the way. They support glue records. They really, you get a domain name from them, and they do what they're supposed to do to register it. Nobody else bothers. Anyway, so I think I've got, yeah, I guess I'll go ahead. It's just, so here's the population of IPv6 sages in the world. There are only 163 of them in California, and another place, Texas is number 2 with 42. So as you can tell, you people all succeed, that's about another 10. Will be a significant portion of the entire population of IPv6 sages in Texas, which we certainly are, because at my college, I'm 22, I think it's 24 now. So I'm about, 1/5 of the entire population of IPv6 sages in California, and about 1% of the ones in the whole world. There's only 1,700 IPv6 sages in the whole world. And this is, as far as I know, the only certification you can get in IPv6 right now. Which is, we're supposed to have this stuff deployed by like last year, and we don't even have the names for the terms. We don't have a textbook that's worth anything. They couldn't get the textbook I asked for. They got some other book. I'm not even sure I've seen the book we're actually supposedly using here. And the books are all junk anyway, by the way. This is one impediment to teaching this class. None of the books cover the right stuff at the right level at all. If this is the book I think it is, it's the deployment. I got to take a look at it. I went through one. The deployment book is at a high-level management level, not really very technical at all, about how to decide how to plan it. Yeah,
He's got one here that he likes.
yeah. Oh, you do? You got a good book?
That's all right.
The Cisco, yeah, Cisco self-study. Yeah, implementing in Cisco network. That's right. If you're Cisco-oriented, Cisco has some stuff. That's right, and that might be the way to go. But I mean, for like a Net Plus level, yeah, but for a Net Plus level IPv6, that would be too hard, I think. And see, but for an introduction at a Net Plus level, there isn't a friendly textbook at all. I'm pretty much stuck with web resources. There's one called, the one I tried to get here called, I forget what the name of it is now, but the point is, it's hard to get anymore. It's kind of old from 2005, and it's too technical. It's almost just a list of RFCs with every little bit. They tend to be too hard. Anyway, so we'll do what we can. But anyway, the #1 motivator for IPv6 experimentally is this t-shirt. If you become a sage, you get the t-shirt. This had an enormous effect. This is when they announced the t-shirt. How many people taking these tests? This is what really drives network professionals. In case you had any other illusions, this is what makes people care. So you can get this shirt too. Anyway, probably look better on you too. So anyway, I think I'm not going to talk about the security problems right now. Let me just get you started. I just want to get down to the summary of what we're going to do in this class. And then people can start doing it. Because there's not going to be much lecture in this class. I've talked enough for right now. Only a 1/4 of time in lectures, maybe even less, mostly hands-on projects. So here's the first thing I want you all to do is get certified as a guru. Get all the way to the top so you've done all the server-side setup and all the client-side setup. The next thing is the network setup. And for that, I've got a bunch of packet tracer activities where you can practice doing IPv6 routing with EIGRP, RIP, NG, and I think I have some OSPF in there too. All those do have a version 6, IPv6 versions. And then we can start setting up on real routers, which I don't have any projects written for, but I don't think I'll need them. You people are all Cisco experts, and we'll see. So here's what you do. You register at Hurricane Electric, then you do a noob test to just show you basically understand the concept. Then you connect with the GoGo6 client, and you become a client over IPv6, so when you have connectivity, that makes you an explorer. And then you set up a web server. Here's where you must buy a real domain name, because they're going to look for you through DNS, and you have to really register it. Although if you have a domain name and you don't mind adding a quad A record to it, you can do it. However, I should warn you here, this is something that Google found and the Japanese telephone company found. If you have a server that's working on IPv4 and you add a quad A record in DNS, you will break connectivity to a significant number of your existing customers because of Apple primarily. versions of Apple OS X have some kind of defect. So if they get an A record and a quad A record, they try to go with IP version 6 preferentially, which is the correct behavior, but they fail because they attempt to set up one of those automatic tunnels that doesn't work. They fail to connect, and then they fail to fail over to IP version 4. They just give up and can't connect. So when Google added the quad A record to Google, a bunch of people couldn't reach Google anymore. And the telephone company, they said when they put on the quad A record, the Japanese telephone company, they said the phone started ringing and it never stopped. They said it was like 25% of their customers couldn't reach them anymore. They said that was really unacceptable. Google said it was more like 0.2% in America. So whatever, and they were trying to track down the problem still, but I noticed Google has put the quad A record back on. But I think what they said at Google at the conference was they have a system of detecting whether you appear to be using IP version 6 successfully, and they have like a whitelist. And they only show the quad A records to people they know are actually working on IP version 6, which is not what you're supposed to have to do at all. And they're like apologizing, you know, it's ridiculous. You have to have like a list, like we were blocking spam, a list of IP addresses that we recognize as IP version 6 capable. But that's why what's happening right now is everybody has two web presences, an IP version 4 presence and a separate IP version 6 presence, which is awful. That's not what's supposed to happen at all. That's never going to work for a transition. People are supposed to remember when I pick up this cell phone, go to v6.facebook.com, but when I pick up this cell phone, I have to go to facebook.com. That's never going to work. But that's where we're at the moment, until all the end devices really have version 6 connectivity, and that's something you got to get used to. People say their stuff is v6 compatible, but it's not. They don't have feature parity. Half the features work, half of them don't, and the ones that do work are typically implemented in software instead of hardware, and they don't really work very well. So, just like you'd think. Anyway, then you set up a mail server. Oh yeah, the other dirty trick is you probably would use Apache. I would. You can't use Apache. Apache does not listen on version 6 on Windows. On Linux it does, but not on Windows. And I have found many, many forum posts of people whining and complaining and trying to fix it, and nobody can figure it to work. So you have to use IIS, as far as I can tell, to get version 6 to listen on Windows. And for email, I didn't have much fun finding an email server that would listen on version 6 either. Most of them don't. But I found that Apache James does, written in Java. It listens on Windows 7 over IP version 6. By the way, I don't suppose it'll affect any of you. It might very well affect your students. If you have students with home editions or starter, they're hosed. I have one student that actually succeeded in doing this on Windows 7 starter, and it was miserable. She made a list of all the horrible things she had to do to add all the missing pieces in to make this stuff work. They should at least have professional versions of Vista or Windows 7. Some of my students did it on XP. It's not much fun on XP. XP doesn't really have full IP version 6 support at all. One of the things that really stopped me dead, one of the reasons I gave up in 2007, is because I tried to set up a DHCP server to send out the IP version 6 address, and it wouldn't work. And I said, well, I must just be an idiot. If I can't even make DHCP server, this is just useless. Then I found out that Windows XP does not contain a DHCP client for IP version 6. Like, it doesn't even have that. You have to use static addressing. Of course, DHCP is not the recommended way to distribute IP version 6 addresses anyway. But anyway, I don't much recommend XP. That's why I made them take XP off these machines and give us Windows 7 for this class. Windows 7 is the way to do this. Windows 7 really works. XP halfway works. The home editions don't work very well at all. Anyway, then after that, you do a whole bunch of DNS tests and you make it all the way to the top. That's the plan here. And you get the t-shirt and eternal glory. So that's the plan for the class. So I want to get out of the way and let people get started doing it. Let me point out where the projects are, because I did not print them out. I put them right here on my webpage. Go to samsclass.info. And I got a board. Let me put the all-important facts. Here's another one. We're supposed to take a break at 10:15 and lunch from 12 to 1. So samsclass.info. And then you click IPv6 materials. And then the projects are right at the top. And so what I would like you to start doing now is project 1. And I'm happy to go around and help people that have any troubles with it. But these two things here, I've used, and this is how I recommend adding it to your classes. I added it to my NetPlus class and my Cisco classes, CCNA 1 and 2. as extra credit last semester, and I had a lot of students succeed just by following these projects. So that's how I'm solving the problem which every other teacher is facing, which is you're teaching something like introductory networking, there's no IPv6 in there at all, how do you add it? And add it with this Hurricane Electric stuff. This is really at the right level, so even Net Plus students can reasonably succeed at this. It's only for the more advanced ones, it's relatively hard, but I gave them a lot of extra credit, and they were motivated, and a bunch of them did this effectively instead of taking the final. It's like as many points as the final would have been.